try to test our program. So we have the block we just created. We are going to try to display the figures coming out of that block. To do that, I'll come to the action section and then I'll pick the EV3 display block. So display, what do I want to display? The figures from the pots or the block we just created. To do that, I'll change the mode to display text in pixels, and then I'll change the source to a wired text. So I'm going to wire the text into this display block. So I select wired, and I'll be wiring the output from this block into that box. So I wire that into the text section. I can decide to see how that is going to appear. So I have, let's see. So it's going to appear, that's too much to the top, so I'll say let's drop that a little to the middle. Okay, good. So whatever comes out of this block is going to be displayed on the EV3's display. And to keep this figure on the display for us to see it, I'm going to select or pick a loop and drag this small program into the loop. So without the display, let us check without running this program. Let's see what percentage of reflection we are recording from our EV3. So I'll move to the EV3 now. And as you can see, it is on the black portion or totally on the black, and we are recording 15% reflection, a little different from what we use. We use 16% reflection. We can go through the mathematics and then come up with the appropriate gradient again. And then on the white surface, we are having 79% reflection. So it is now on the white and we are recording 79% reflection. Now, I'll go on to run the program and then we'll check the figures that come out of the block. So let us run the program now. And as you can see, it is on the black portion or totally on the black, and we are recording 15% reflection, a little different from what we use. We use 16% reflection. We can go through the mathematics and then come up with the appropriate gradient again. And then on the white surface, we are having 79% reflection. So it is now on the white and we are recording 79% reflection. Now I'll go on to run the program and then we'll check the figures that come out of the block. So let us run the program now. I'll say download and run. And now it is running and we can see on the white surface we are now recording 101.6. So we have opened the range from 70, I think we had 79. We've opened it up to 101. And then I move it to the black surface, fully on the black. And then I have an absolute 0. So as we can see, the figure has been calibrated and this light sensor is now outputting values between 100 and 0. Slightly above 100, possibly coming from the variation in the environment, because as you could see, we were recording about 79 instead of the 78 we used for the calculation. But you can go through the calculation again once you pick your figures and come up with the appropriate gradient and intercept value. So this is how we calibrate our light sensor. In the coming sessions, we'll be using our calibrated light sensor blocks to see how we can improve our finite state machine and also to improve our continuous time machine. Thank you for watching this video. Like our video, share with others, send us a comment if you have any questions. We will address that. My name is Michael Wilson, Chief Trainer for the Ghana Robotics Academy Foundation and Technologist at the Council for Scientific and Industrial Research. Thank you. Bye-bye.